Welcome to this video where we will look at the equation of a linear function. We will see how we can determine the equation from the graph. In general, a linear function can be written in the form y equals mx plus c. Y and x are the variables. M is a numerical value which represents the gradient or steepness of the line, and c is a value that represents the y-intercept. In other words, the y-intercept is the value on the y-axis which is intersected by the line. To determine the value of the gradient from the graph, we need two distinct points on the line. Look at the graph on the left. We have 2 points A and B on the line, each with its coordinates. Point A is represented by the coordinates x1, y1, and point B by the coordinates x2, y2. Using those 2 points, we define a right-angled triangle underneath, as you can see, and we give names to the vertical side and the horizontal side. The vertical side is called the rise, and the horizontal side is called the run. The gradient is given by the ratio rise over run, and using our coordinate values, the rise is y2 minus y1 and the run is x2 minus x1. So we can determine the value of the gradient m by using the relationship m equals y2 minus y1 over x2 minus x1, which is what is shown on the right. However, if we have a horizontal line anywhere on the Cartesian plane, as shown here, the gradient is 0 and therefore m equals 0. In this case, we have a horizontal line passing through the y-intercept of c. And if we then substitute m equals 0 in our equation y equals mx plus c, we have y equals 0 times x plus c, which is equal to c, because 0 times x is 0. Therefore, it simplifies to y equals c. So the equation for a horizontal line on the Cartesian plane is y equals c, where c is the y-intercept. Alternatively, if we have a vertical line as shown, we know that the gradient is undefined. In this case, if the vertical line passes through the x value of k, then the equation for the linear function becomes x equals k. Now let's suppose that we have a linear function whose graph is not horizontal or vertical, as shown here. To determine its equation, we can see from the graph that we know what the y-intercept is. There's the general form, y equals mx plus c. The y-intercept is 6, so we know that c equals 6. We can make that substitution in our equation, and we have so far y equals mx plus c. It now remains to work out the value of the gradient m. To do that, we can use the idea of the previous section where we can write that the gradient is rise over run, so we create our right-angled triangle as shown, and you can see that the rise is 4 because we are starting from 2 and going up to 6, so 6 minus 2 is 4, and the run is also 4 because we are starting at -4 and going to the right to 0, so in terms of magnitude only, the run is 4. So the gradient becomes rise over run, which is 4 over 4, which equals 1. So we can make that substitution in our equation, and we have y equals 1x plus 6, or we can leave out the 1, and we can write it also as y equals x plus 6. What about if we don't know the y-intercept, as shown here in this graph, but we are given 2 points A and B? So firstly, let's write down the coordinates of each of those points. There they are. Coordinates of A, -2, 8, and the coordinates of B, 5 and 3. Let's work out the gradient first using rise over run. And there's our expression for the gradient, y2 minus y1 over x2 minus x1. And making the substitutions, we have 3 minus 8 over 5 minus -2, which simplifies to the fraction -5 over 7. So putting that value for the gradient in our equation, we have y equals -5 over 7x plus c. Now to determine the value of c, the y-intercept, because we can't actually read it from the graph, we can substitute either coordinates from point A or the coordinates from point B for x and y in the equation and work out the value of c. Either way will give us the same answer. I've chosen the coordinates for B, 5 and 3. There they are. And you can see that when I've made the substitution with x equals 5 and y equals 3, we have the expression 3 equals negative 5 over 7 times 5 plus c. And solving that for the value of c, we have c equals 46 over 7. So our final answer for the equation becomes y equals negative 5 over 7x plus 46 over 7. Please check my website for other interesting things relating to mathematics.